Hi, in this video we're going to have a look at a couple of special properties of trig, and I'm going to do it over two videos. In this first video I'm going to look at a question that is sometimes given. It's not very frequent, but I thought it was worth having a look at very briefly. And let's just say we've got this scenario here where we're told sine of theta is equal to 0.6, and we're asked what is the cosine of pi on 2 minus theta. Now, to get a handle on this, I'm going to take it back to the right-angled ideas. And even though theta might not be an acute angle, it still works with the theory I've got here, based upon how the unit circle works. So we're pretending theta is an acute angle, even though it might not be. So if theta is an acute angle, then we have this kind of scenario here. We've got a right-angled triangle. I've arbitrarily chosen theta to be here. I've got a value of 1 here for the hypotenuse, and then I have labeled the other angle as being alpha. That's just a symbol for alpha. Now, because it's a right angle triangle, this angle here is pi on 2, 90 degrees. And so these two angles here must add up to pi on 2, because pi on 2, 90 degrees, plus pi on 2 would give me 180 degrees pi. So that means that in terms of alpha, we can say that alpha is equal to pi on 2 minus theta. Okay. Now, the reason why I've done that is because you can see here I've got an expression alpha, which is pi on 2 minus theta, and we've got cosine of pi on 2 minus theta over here. Okay, I'm going to zoom all the way out, and then I'll fill in the missing blanks here, just so you can see everything at once. Well, let's remember that sine theta is opposite over hypotenuse. And so in this instance, in this diagram here, sorry, we've got opposite over hypotenuse, which is equal to 1. So what does that mean about the value of this side length here? It has to be 0.6, right? Because of this. So sine of theta equals opposite over hypotenuse, which is 0.6 over 1, which is just 0.6. Cosine of alpha is adjacent over hypotenuse, so that also is going to be 0.6 over 1. But alpha is just pi on 2 minus theta. So that means the cosine of alpha can be written as the cosine of pi on 2 minus theta, which means that also is equal to 0.6. So there's a little illustration about how these complementary angles work. Generally speaking, we can say that sine of theta is equal to cosine of pi on 2 minus theta. And I'm hoping that you can see that in a similar fashion, the sine of the cosine of theta would be the cosine of pi on 2 minus theta. So we call them complementary angles because this angle and this angle here would add up to pi on 2, or 90 degrees. So they're called complementary. So in a nutshell, you could say that the sine of 30 is equal to the cosine of 60. The cosine of 45 is equal to the sine of 45. The cosine of 10 is equal to the sine of 80. The sine of 17 is equal to the sine of 73, etc. That's how it works. And generally speaking, this relationship does get extended so that theta can be any angle, and it'll be true that sine of theta equals the cosine of pi on 2 minus theta, even if theta is, 3 pi on 7 or something like that. So let's have a look at a couple of examples to finish off this video. And in the first question, we're given this equation here, cos of theta is equal to the sine of pi on 12. And what is theta? So effectively, all it's really saying is we need to work out the complementary angle, between here and here, and then we'll be good to go. But I'll do it a little bit more formally. We've got the result that cos theta equals sine of pi on 2 minus theta. So let's do that. This is actually a better way of thinking about it, because sometimes this might not be an acute angle, but this relationship still does work. So we've got cos theta equals sine of pi on 2 minus theta, and on the right-hand side, we just leave pi on 12. Now we're going to do a classic mathematical trick of saying, well, if we've got sine of something here and sine of something here, then these two things must be the same. We call it equating arguments, where the argument is the value that we're inputting into the function. So we're saying that pi on 2 minus theta, therefore, must be the same as pi on 12 by equating arguments. And now we just solve for theta. It requires a little bit of maths, but you know what? We can get there. I'm going to add theta to both sides. So I'm going to add theta. I would usually do this in one step. I'm just going to do it in two so it's not too tricksy for you. Like so. And then I'm going to subtract pi on 12 from both sides. I'll flip the theta onto the other side just so that we've got our left to right reading, which is pretty normal. So we've got pi on 12 minus pi on 2. Now I'm going to change the, sorry, wrong way around there. I've got pi on 2 minus pi on 12. Now I'm going to change pi on 2 to a fraction over 12. So we've got 1 over 2, 1 pi over 2. So that's going to be 6 pi over 12 minus 1 pi over 12. And that's going to be 5 pi over 12, which I'll just squeeze into this box here. I should put the equal signs underneath each other. Okay, next example, cos theta equals 0.8. What is the sine of pi on 2 minus theta? Well, that's even easier, really. We just start off with sine of pi on 2 minus theta, and we use the result that sine of pi on 2 minus theta is just the same as cos of theta. And we've been given cos of theta up here. It's 0.8. So therefore the answer is 0.8, and I'm done. Now, the reason why I put that example in is because I wanted to reinforce to you again that you need to check the question carefully. At no point does it ask you to work out what theta is. This is a very legitimate non-calculator question. Theta is probably some very random angle. It doesn't matter because you're not asked for theta. You're asked for the sine of pi 2 minus theta. So you can use that very simple relationship to finish off the problem. Don't get sucked into thinking that you have to work out theta if it's not asking for theta. Okay, that'll do for this video. We'll explore some other special properties in the next one.